Hello everyone. So let's talk about the topic of semiconductors. So what are semiconductors? These are the materials that are used in various electronic devices and circuits. They are the partial conductors. By partial conductor, I mean they can allow partially the flow of electricity, which means the flow of current, which implies to the flow of electrons. We can classify between these materials using their resistivity. So we have three types of material. First is metals, second insulators, and third one is semiconductors. For metal, the resistivity is 10 raised to the power minus 2 to minus 8 ohm meter. For insulator, the resistivity is 10 raised to the power 11 to 19 ohm meter. And for semiconductor, as by its name we can say it is semiconductor. That is, its resistivity must lie between metals and insulator. So their resistivity is 10 raised to the power minus 5 to 6 ohm meter. So apart from their resistivity, we can classify these materials on the basis of their energy bands. So how these energy bands are formed and what are energy bands? So let us take an example. Say this is an atom with a valence electron and a nuclei. So this electron has its own energy, let's say E. And let's say this atom comes in contact with another atom with the same nuclei and valence electrons. So now this electron will interact with this one and this electron will also interact with this. So now these electrons does not have the same energy as it was alone with energy E. So its energies have changed. Similarly, if there are more atoms, suppose these are the atoms and every atom has its valence electron. So all these valence electrons will interact with all these valence electron present. So now this time the energy is totally different from above two situations. So let us see what happens for each of three components of metals, insulator and semiconductors. So let us say this is the atom of same material and let us draw the energies of these electrons. So let's say the valence electrons here have some energies. So let us draw it in here. So suppose their energies lies here. And this is the free electron. Its energy will lie somewhat here. So this is called the conduction band, which represents the energy of free electron. And this is the valence band, which represents the energy of valence electrons. And this is called the energy band gap, which is written in Eg. And for another situation, suppose there are two free electrons. So we will draw its energy levels. So this will be the energy for valence electron and this will be the energy for conduction electron, which are the free electrons. So here this is called the band gap again. So in the third case, the valence band and conduction band overlaps. So the electrons lies in both the regions, in conduction band and in valence band. Here, the band gap is not available, or we can say there is no band gap. So this is the case of metals. Here, the energy band gap is less than 3 electron volts, which is the condition for semiconductors. While in case of this scenario, the band gap is greater than 5 electron volts, which is the situation of insulators. So here we can say that metals does not have any band gap. That means the amount of energy is required to excite the electron from valence to conduction band for the conduction is not required, because even at the room temperature there are a number of free electrons available. In case of semiconductors, we have some free electrons, but when we give some energy for valence electron to reach at the conduction band, the energy is required is less than 3 electron volts. So this is the semiconductors, where we can choose how we want our material to behave. It may behave like an insulator if we do not provide any energy, and if we provide some of the energy, it behaves like a conductor. While in case of insulator, the energy is required is quite more or larger. So, by looking at the energy band gaps, we can classify among these components. Thank you for your kind attention. I will see you again.